Welcome to Engineering and Project Management channel. I'm Imtiaz Khan. So today our series of mathematics, we're gonna discuss about the matrices. Matrix is the singular and matrices are the plural of matrix. So what is matrix? Let's start. So matrix is the arrangement of real number in a rectangular type of shape where the two brackets are used to enclose it while two sides remains open. So the shape is like this. This is matrix where we arrange the real number. So that's called the matrix. It was introduced by the mathematician Arthur Cayley in 1860. So now let's start. So let's say this is a matrix A, B, C, D, E, F, or B is equal, let's say 6, 5, 4, 2, 1. This is an example of a matrix. So what I have to mention here that like in matrix A, B, C, D, E, F. So this A, B, C is a row, and this is the column like AD, and A, B, C, D, E, F, A, B, C, D, E, F are the element are members of the matrix. So this is ABC. This is a rectangular two rows and three columns. The columns are vertical and the rows are horizontals. So this is horizontal, the rows, and this is vertical. In a matrix A, this is 2 by 3 order matrix in which the rows are 2's and the columns are 3's. If the number of column is equal to the number of rows, then it's called equal a square matrix. Like A is equal to the matrix AB and CD are B like this. So this is a square matrix of order A 2 by 2. So 2 rows and 2 columns. And if the rows and the columns are not equal, so it's usually called rectangle matrix. So this is it's called a diagonal matrix. The diagonal matrix are those when let's say if this is a rectangular matrix, so this is a diagonal 1, 4, 2, and either side of the rectangle is 0. So it's called diagonal matrix. Addition of matrix. How to add the two matrices? So let's A is a matrix, square matrix, A plus B is equal to square matrix. So we simply add this one, 1 plus 6 on 2 plus 7, 4 plus 3 here, and 5 plus 2. So this is it's called the addition of the matrices. Subtraction of the matrices. So let's say if A is this and B, these are the same orders. So it's a 1, 2, 3 rows and 2 columns. The B is also 2 rows and 3 columns. So A minus 1 like this, and 3 the same. Only the sign is changed. If the order are same, then you can add the matrices. Multiplication of matrix. It's a third one. So let's say A is a matrix 1, 3, 0, 6 multiplied by matrix B1. So here is the multiplication is possible if the number of rows in column A in matrix A is equal to the number of column in matrix A is equal to the number of rows in B. So then the multiplication is possible. Let's see. So the number of column in A is 1, 2, and the number of rows 1 and 2. So the 2 rows and 2 columns. So multiplication is possible. So let's multiply A by B. So simply 1 by 1 and then plus 3 by 1. You have to multiply this row with this the first element of this matrix. The second one is 0 multiplied by 1 plus 6 multiplied by 1. So 2 plus 4. So this is 6 by 6. So this is A and B multiplication. But if you want to multiply B to A, so then it's not possible, because the number of column in B is not equal to the number of rows in A. So AB is not equal to BA. Identity matrix for the addition. So additive identity, if you add 0 to any matrix, it will remain unchanged. So in arithmetic, it is called additive identity. It's called zero matrix. So if you know mathematics, so if you add 0 to matrix, so it's remain unchanged. This is matrix of addition. Matrix is simple minus sign. B is a matrix, then the minus is the additive inverse. Identity matrix of multiplication. If matrix I is multiplied by B, let's say IB, identity matrix, so where the value of B does not change, so it's called identity matrix. Identity matrix is usually a diagonal. The diagonal is 1 1 and 0 0. So if you multiply this with another matrix, so the matrix will remain unchanged. So that's called identity matrix. Determinants of matrix is simply is the absolute value, you can also say. So let A is equal to matrix E F G H. So absolute value A, just change this large bracket. So what you do, you multiply this diagonal element EH minus FG. So this is always a real number. It's always a positive real number. So it's called determinant of matrix. And it's always a real number. So adjoint of matrix. Adjoint of matrix, let's say this is B. B is a matrix, C, D, and E. B is a square matrix. So what do you do in adjoint? Adjoint, you just change the position. You're gonna change this C, you're gonna bring it here, and the B, you're gonna take it there. You're gonna replace B to C and C to B, and change the sign of this these two elements, diagonal elements, D minus D and minus A. So it's called adjoint of B. Just if the square matrix A is not equal to 0, and if a matrix B is not equal to 0 or multiplied, then AB is equal to BA is equal to I, identity matrix. Then B is multiplied by, so it's A inverse. A inverse mean when you like this in mathematics, if it's like this, so you can write down this B is equal to 1 by A. This is a simple equation. A inverse is equal to 1 determinant absolute to adjoint of A. So you can prove this equation if you go like A is equal to A and 1. So this is a question. So let's say A is this and adjoint of A is this one. So absolute or determinant of matrix, you're gonna multiply this one 4 into 1 and minus you're gonna change, so minus 2 into 3. So you're gonna change the and this is the adjoint. So this is 2, and then so what we got A, this one. So this is a simple equation. You can prove A inverse. Yeah. Let's say this is A, matrix A 2 5 and 3 6, and you multiply it by a real number, any real number, like let's say 2. You multiply this matrix 2 5 3 square matrix by 2. So you're gonna multiply this one 2 cross 2, 2 cross 3, 2 cross 5, 2 cross 6, and you will get this one. So you can multiply any real number to the matrix, the position will not change, but the element will. It's called scalar multiplication. So I hope you got the idea about matrices, and thank you and have a nice day.